Hello everyone, welcome to Nafi's Learner's Zone. So today we are going to discuss about the heating effect of electric current. What is heating effect of electric current? So you know that electric current is nothing but a form of energy. Energy which has been derived from some other means the law of conservation of energy, that energy can neither be created nor be destroyed, but it can be transformed from one form to other form. So you know that electricity is transformed from so many other form. Suppose if it is in a dry cell or the battery, we converted it from chemical energy. In a hydroelectric power plant, then there are a lot of process takes place. The potential energy of water converts to kinetic energy of water, then kinetic energy makes the turbine rotate, that means it converts to mechanical energy, then mechanical energy is converted into electrical energy. So like that, many different ways of production of electricity, uh, means the different form of energy we had converted. Wind energy we had converted from wind to electricity, we can convert there. So all those we'll discuss in source of energy chapter. So here what you have to learn is, when we convert one energy to other energy, you should know that most part of it will be wasted in the form of heat. So here also, when we use electric current, say suppose in a bulb, in TV, in this mobile phone, then there is a lot of energy which is wasted in heat. So now when you are watching this video, you might be, if you had watched it, if you had used this mobile for a longer time, you may notice there is some heating in the mobile. Any brand of mobile it might be. So it depends on the particular time it start getting heated. So that's it's general. It's because what happens, the electricity which is used, which you are converting into different, like this light and different energy here, the sound energy, light energy, all those which is given by mobile, along with that the heat energy also it gives off. Have you ever touched a bulb, lighted bulb? You may feel that it's too hot. So why it's hot? Because it's generating heat. You can see that the old filament bulb used to get heat so much. Then CFL, it reduced so much. And now LEDs, rarely it gets heated, very less. Uh, what is the difference in that, and why that we'll discuss in some other video in future. So now what we are saying about heating effect of electric current. So that what I said about the bulb getting heated, that is the heating effect. The heater, the electric heater, that's also heating effect. So what's the difference in both? In bulb, do you wish the bulb to get heated? No, because that's a waste form of energy. But whereas in electric heater, you need heat. You need heat. In electric iron, you need heat. Okay, at some places the heat was generated as a waste, but that property itself being used in some devices to generate heat. How does it, how much heat will be generated, all those, the by finding the formula, all this we have to discuss in this chapter, right? So here you have to remember lot of formulas in this part of this chapter. That is important for your exam point of view in solving some problem, and sometimes in multiple choice question also about this formulas also being asked. So I am presenting you a chart here where you'll get every formula related to this chapter here. If you learn this chart, if you practice in your home, in your school later on, if you practice this, it's best for you, because this chapter problems will be based on these formulas only. What confuses is the formulas. Solving mathematically, it's so easy. I'll show you in further videos about the problems as I mentioned in the previous video. So this formulas are very important. Now for time being, learn these formulas. Okay, so there are different formulas of power. How do we calculate power? Power is the rate of doing work. And so that how, what are the formulas, you can check out here the different formulas, different relations which is given for you in problems. We'll discuss further about that. The what is very important now to discuss in this is the formula H is equal to I square RT. What is this? This is known as Joules law. Joules law. You may get a direct question about define Joules law, write its mathematical equation. So what is Joules? This equation only you can represent in the words, that is Joules. Joules law can be defined as the heat is directly proportional to the square of the current and the resistance of the conductor and the time at which the current is flown. So that can be mathematically represented as H is equal to I square RT, where I is the current in ampere, R is the resistance in ohm, and T is the time in seconds. Okay, by using this you can calculate the heat generated by a conductor or the different entities by interchanging this formula. This is very important, and as I told you about power formulas also, this also you have to go through. Okay, fine. So what next is? The next is about, let's discuss theoretically about the application of this heating effect. There are two major applications we'll discuss. More you can study by yourself. Two major things we discuss so that you'll get clear about this topic. One thing about bulb I told you, there the heat generated is actually, once it is used for lighting also, some it is generated too high. So there in bulb we convert heat energy into light energy. How do we do that? We use a metal of very high resistance and very high melting point. Generally, you know that which metal is used in the filament bulb. Yes, it's tungsten. Okay, tungsten is a metal which has very high resistance. Resistivity is very high of that material, and it has very high melting point. The melting point of that is 3380 degrees Celsius. It is too high. It doesn't melt quickly, as it doesn't oxidize quickly, and it has a high resistivity, due to which here in the filament bulb we use tungsten. Okay, those are the properties which we had discussed in the previous video also, which makes a good conductor for this heating effect. Okay, there it's tungsten is used. Same way the electric heater, electric iron box, all those, there also we should use a material which has high resistivity, high melting point. Okay, so that it should not melt and break. It should have resistivity also. It should resist the current. The more a material resists the current, more it gets heated. Okay, if a material cannot resist the current, then it get melt easily. It doesn't get heated. If it get heated more, it melts. So the second example is the opposite of these, where we use some materials with low resistance and low melting point. Sometimes it is required, where you have studied it in your lower classes. Hope you know about the fuse. So fuse is a safety device which is used in the electric circuits. Usually the fuse is made up of an alloy of low melting point and low resistance. Low resistance metals like copper, aluminium, such metals are used. Lead, many metals are used in different fuses. Different can be used. An alloy of low resistance and low melting point must be used. Why do we use this? Because when the higher magnitude of current passes into the circuit, the fuse which is connected in the beginning of the circuit, what happens is, when the higher magnitude current passes through the fuse, because of low resistance and low melting point, it melts. The fuse wire melts and breaks. So as it breaks, it doesn't allow the electricity to pass inside. Means higher magnitude, which may cause some damage to your devices in your home, will be prevented by fuse. So fuse actually commits suicide to save your devices inside your home. Imagine your TV, your washing machine, fridge getting damaged. How much you are going to lose economically. So to prevent that, this fuse is fixed in the circuit. Remember, it is always connected in series. Okay, that fuse wire melts and break when higher magnitude current is passed. Okay, that is the heating effect. That's about the example of heating effect of electric current. You should remember this. This is that's all about the theoretical aspect of this chapter. What is left is problems based on different thing. So problems on Ohm's law, problems on uh, different thing like heating effect, power, resistance, combination of resistance, all those things that we are going to discuss in the next videos in future. So for time being, I have posted here some questions related to this chapter, some problems. You can try out yourself. If you are having any doubts, you can ask me anytime. You can write down in the comment section below, or you can write it to me in my any of my you can contact through any of the media. You can contact through mobile or anything. I will solve your doubts. Future problems based on problems of videos, I'll make it later on. So thank you so much for watching. That's about the electricity. Let's if problems, if I could do, I will start it soon. If not, I'll go with chemistry in the next video. Thank you so much. Bye bye. Please like, share and subscribe to my channel. Press the bell icon. Thank you.